so it takes some time. The main concept behind that is that you, when you're training your classification scheme, you're using AOIs to separate forest from water and urbanized or betonized areas or streets from other bodies. And due to this making a shape or whatever, you will make some failures in your drawing of the shape, and you will always cover maybe 1 or 2 pixels in your area of interest that are not part of the class. And especially, okay, water bodies are really good to distinguish between, so you only have 5 pixels in the areas of your water bodies that are afterwards part of the urban class using the minimum distance file or the minimum distance classifier. But let's keep that open and see what is happening when we are using the contingency table with the maximum likelihood classifier. Once again, go for that. And yeah, just to show you the other values, we have one idea regarding the separability of the suburban and urban, or the urbanized classes, and you can also see them here. So you have a big overlap in these both in these 3 classes here. So you have dense urban, which is 27% part of the urban class, and so on. So you have 3 major areas where they can belong. So also fields, which is quite unuseful for future analysis. But having a look on the maximum likelihood classifier, you can see that is performing much worse, because the water class here is producing 214 pixels as part of the dense urbanized area. So the job of this is not that good. But in the other way around, the class of dense urban areas is much better here. As you can see, 67% of the dense urban area, which was part of the reference data, was afterwards also in the dense urban class, and in this case we only have 34%. So you have to be very careful in judging which classification scheme is better. But in the end, you can probably say, okay, maybe just compute the correct classified data and making a mean of it, and so you can make sure which is in overall the better approach to produce a classification scheme. So this is one, or this is the second part, and the mostly used part is to go with the accuracy assessment. What is that for? So normally you are not only using Alice Imagine, you will also go out in the field and have some kind of reference data you can use to provide some information about your area, and not only the Landsat image, which was maybe 2 years old, or is 2 years old, before you will work on the project. So we will go for that with the accuracy assessment, and normally you will go out in the field, search for a special location, mark it with GPS, and say, okay, you have your catalog of classes, and you will classify this area of about 900 square meters as a certain class. We will do that using the accuracy assessment, and therefore first we have to combine this table with the classified image. Therefore we will use the maximum likelihood classifier, and in the end we will create random points, and we will create random points all over the scene. So we will start maybe with 200. We will just create a lot of random points, and as you can see here, class values are still blank, and also reference values. So first we have to see our class values, and as you can see, there are some classes containing there are some points that are with assigned with the class value 0. And the problem is that the accuracy assessment is producing not only points here in the covered scene, but also in this area here, which is totally blank, and so you have not a class assignment. Therefore, we will just make a right click here in the point values, and in every kind of table in Atlas Imagine you can probably choose criteria. And this is standard SQL, so you will use the class values, which is the same as 0, to identify every ID or every reference pixel using this information. So we will select that, and as you can see here, it's probably done, and we will just delete the selection, and in the end we will have only points that are in our scene. So what is the normal way to do that? So you will have to view it in another viewer to search for the real class behind that. So therefore we will open the original data, and we will select a viewer to view these points. So we will show this selection, view, show current selection, and as you can see here, there are certain points in the area which are now which we can now evaluate. But go for that ID number 18. You have to assign a class number. So keeping in mind that we have normally just 8 classes. So why is that class number 12? You will get that information just by clicking in the minimum distance file. We will oh no, we are using the maximum likelihood. So maximum likelihood, oh, where are you? There we go. And raster, and having a look in the attributes. So there's some kind of ghost classes, I maybe call them. And as you can see here, the color of these ghost classes is 0. So you will have that. And there's no class name assigned. So class number 6 means that we are here in the pixel value of 6, and this is probably grass. And is that class ID number 18 is belonging here. It's class number 9. Looking in the attribute table, class number 9 I've said, so this is field number 2. Yeah, normally you will switch that off, so you will hide the class values and just looking in the attribute table and search for the pixel. So this is ID 18, and probably it is field number 2, so it's class number 9. Go with that, and as you can see here, now the color of this point has changed, that you can differentiate between points you have already searched for and points that are still uncovered with information. So there's another point, ID number 13. This is probably grass, so class number 6, I think. Yeah, and it was ID number 13, ID 13, class number 6. So you will go on with that for a lot of points, as you can see here. I will do it in some minutes, and I will show you the results in the next video.